Imagine a force 1,000 times more powerful than the atomic bomb that leveled Hiroshima. Let that sink in for a moment. That's the staggering power we're dealing with when we talk about the hydrogen bomb. This isn't just another weapon in the arsenal. This is a force that, in a single moment, can obliterate entire cities, erase decades of history, and change the course of civilizations. Consider the atomic bomb. Its destructive power is immense, yes, but it's a mere firecracker in comparison to the hydrogen bomb. Remember, we're not talking about double or triple the power. We're talking about a force 1,000 times greater. A force that can cause destruction on a scale that's almost unimaginable. This is a weapon that pushes the boundaries of human ingenuity and innovation, but at a cost that is sobering. Yes, we're talking about the hydrogen bomb, humanity's most devastating creation. The origins of the hydrogen bomb date back to the height of the Cold War. This was a time fraught with political tension, pitting the superpowers of the United States and the Soviet Union against each other in a fierce ideological battle. But this wasn't just a war of words or ideologies, it was a race for supremacy, a race that extended into the realm of nuclear weaponry. The hydrogen bomb, also known as the thermonuclear bomb, was the next evolutionary step in this arms race. It was a weapon of mass destruction, far surpassing the destructive capabilities of the atomic bombs that had been dropped on Hiroshima and Nagasaki. The concept of a thermonuclear weapon was first proposed by Hungarian physicist Edward Teller in the late 1930s, but it wasn't until the mid-20th century, with the Cold War at its peak, that this idea was brought to fruition. The United States, feeling the pressure of the Soviet Union's growing nuclear capabilities, embarked on a mission to develop this unprecedented weapon. The project was shrouded in secrecy, led by some of the brightest minds in physics. It was a monumental task, one that required a deep understanding of nuclear fusion, the process that powers the sun itself. They sought to harness this astronomical force, to confine and control it within a man-made device. The road to the hydrogen bomb was fraught with scientific hurdles and ethical dilemmas. There were those who questioned the morality of creating such a weapon, a device capable of unparalleled destruction. But in the end, the geopolitical climate of the time prevailed. The fear of falling behind in the arms race, the fear of the Soviet Union gaining the upper hand, drove the project forward. And so, in the early 1950s, after years of intense research and development, the first successful test of a hydrogen bomb took place. Codenamed Ivy Mike, this test demonstrated a force over 1,000 times more powerful than the atomic bomb dropped on Hiroshima. Thus, the hydrogen bomb was born, marking a new era in warfare. The power of the hydrogen bomb lies in the process of nuclear fusion. So what exactly is nuclear fusion? It's a process that powers the sun and all other stars in our universe. At its core, nuclear fusion is about joining together two atomic nuclei to form a heavier nucleus. When this happens, a tremendous amount of energy is released, much more than in a traditional atomic bomb, which relies on nuclear fission, the splitting of an atom. But how does this process occur in a hydrogen bomb? Well, it starts with two light elements, typically isotopes of hydrogen, deuterium, and tritium. These isotopes are placed under conditions of extreme heat and pressure, akin to the heart of a star. This environment is usually created by a smaller atomic bomb within the hydrogen bomb itself. The immense heat and pressure force the hydrogen isotopes to come together, or fuse, forming a helium atom and a neutron. Now here's where the real magic happens. The fusion of these atoms results in a mass that's slightly less than the sum of the initial atoms. This discrepancy in mass is converted into energy, as dictated by Einstein's famous equation, E=mc squared. And it's this energy that gives the hydrogen bomb its terrifyingly immense power. One more thing to note. The neutron produced in the fusion process is incredibly energetic. It goes on to strike other atoms, causing them to undergo fission and release even more energy. This creates a chain reaction, leading to an explosion of a scope and scale that's hard to comprehend. So the power of a hydrogen bomb doesn't just come from fusion alone, but also from the subsequent chain reaction of fissions. In essence, the hydrogen bomb is a perfect demonstration of how a tiny change in mass can result in a gargantuan release of energy. It's a stark reminder of the immense power locked within the heart of an atom and the staggering potential of nuclear reactions. This process of fusion, then, is the key to the hydrogen bomb's immense power. Over time, the hydrogen bomb has evolved and been refined. When the hydrogen bomb first burst onto the world stage, it was an unwieldy beast. The earliest designs were monumental in size, requiring vast resources for their production and deployment. But as with everything, time and technology have shaped the hydrogen bomb into a far more potent and efficient weapon. Advancements in nuclear physics and material science have been key in this evolution. For instance, the understanding of fusion reactions has deepened, allowing scientists to manipulate these processes with greater precision. This has led to an increase in the bomb's yield, or the amount of energy it releases upon detonation, making it far more destructive than its earlier versions. Simultaneously, the development of miniaturization technologies has revolutionized the hydrogen bomb's design. The bomb's components have been compacted, resulting in a smaller, lighter weapon that retains its devastating power. This has not only made the hydrogen bomb easier to transport and deploy, but also increased the range of delivery systems it can be paired with. Today, a hydrogen bomb can be launched from a submarine, dropped from an aircraft, or even fired from a mobile launcher, making it a truly global threat. Another significant refinement has been in the field of safety and security. Modern hydrogen bombs are equipped with sophisticated safeguards to prevent accidental detonations, unauthorized use, and theft. While these measures don't make the existence of such a devastating weapon any less terrifying, they do provide a small measure of comfort. In the same vein, the advent of computer modeling has allowed for more precise simulations of nuclear explosions. This has not only improved the design and efficiency of the hydrogen bomb, but also our understanding of its potential impact, helping us better comprehend the scale of devastation it can cause. The hydrogen bomb has come a long way since its inception, becoming even more lethal. The advancements in technology and understanding have refined it into a more efficient and powerful weapon, one that holds a chilling reminder of the destructive potential that humanity holds within its grasp. The existence of the hydrogen bomb has far-reaching implications. The hydrogen bomb, a manifestation of raw, unimaginable power, carries with it an equally immense political weight. Its inception has led to a seismic shift in the landscape of international relations, and it continues to shape the balance of power across the globe. In the wake of the Second World War, the hydrogen bomb emerged as the new symbol of military might. It became the ultimate deterrent, a weapon so devastating that its mere existence could prevent conflicts. Countries with the capacity to unleash this incalculable force were thrust into positions of power, creating a new world order. The Cold War era was marked by a race for nuclear supremacy. The United States and the Soviet Union, both armed with this potent weapon, were locked in a precarious balance of power. The doctrine of mutually assured destruction, or MAD, emerged as a grim assurance of peace. The idea was simple: if either superpower launched a nuclear attack, the other would retaliate, leading to the annihilation of both. This chilling reality kept the world on a knife's edge, but it also kept the peace. But the hydrogen bomb's influence extends beyond the battlefield. It has become a tool of diplomacy, shaping alliances and negotiating tactics. Possession of the hydrogen bomb is seen as a bargaining chip, a leverage point in international negotiations. It can bring a country to the negotiation table, or it can isolate it from the international community. The hydrogen bomb also affects domestic politics. How a nation handles its nuclear arsenal, whether it chooses to disarm or to proliferate, can sway public opinion and shape the political landscape. It can be a source of national pride or a cause for protest. The hydrogen bomb, then, is not just a weapon, but a tool of diplomacy and power. It is a sobering reminder of humanity's potential for destruction, but also a testament to our ability to harness that power for better or worse. It is a symbol of our time, a stark reflection of the world we live in. The hydrogen bomb, then, is not just a weapon but a tool of diplomacy and power. The hydrogen bomb encapsulates the terrifying capabilities of human ingenuity. From its birth during the height of the Cold War, this ultimate weapon has been a testament to the staggering power we hold as a species. The science behind it, a complex dance of nuclear fusion and fission, unveils the intricacies of our universe, yet also the potential for unfathomable destruction. Through evolution and refinement, the hydrogen bomb has grown more potent, a sobering reminder of the dangerous path we tread. Its existence has shaped geopolitics, casting long shadows over discussions of war and peace. It's a chilling reality, a stark mirror reflecting our capacity for creation and annihilation. As we continue to grapple with the realities of the hydrogen bomb, one thing remains clear: it represents a sobering testament to the power and potential destructiveness of human innovation.